take a look at the example. Now, if I'm going to use this first technique by define exponential x is equal to exponential of t, or t is equal to ln x. Okay, I will use the definition that we have here, that x to the power 3 times the third derivative of y by x is equal to d times d minus 1 times d minus 2y, where d is equal to dy by dt. Okay, and the second derivative of y times x squared is equal to d times d minus 1y, and the first derivative of y times x is equal to dy. Let's put that definition back into our differential equation. We would get d times d minus 1 times d minus 2 plus 3d d minus 1 plus 3d y is equal to 0. D square minus 3d plus 2 plus 3d square minus 3d plus 3d y. D to the power 3 minus 3d square plus 2d plus 3d square minus 3d plus 3d y equal to 0. You've got d to the power 3 plus 2d equal to 0. I'm sorry, y equal to 0. So that means we have the differential equation like this. So we have only yc, right? So our characteristic equation is m to the power 3 plus 2m equal to 0. We find 3 roots of m, which is equal to 0 plus minus square root 2i. So the answer is just that y is equal to c1 plus c2 cos square root t plus c3 sin square root 2 times t. But we know that t is equal to ln x. So that means our y is equal to c1 plus c2 cos square root 2 ln x plus c3 sin root square root 2 ln x. See, we don't need to use any cases that we just talked about, but whatever we are doing here, we just using the 4 cases that we learned previously from the homogeneous differential equation with constant coefficients. Now, if we want to do the other way by assume y is equal to x to the power m, you can do that too. Okay? I mean, it just depends on you. It's up to you. If you want to remember 4 more cases, then you can. I mean, if you want to. The second method that we are going to do, by assume what? Y is equal to x to the power m. From here we get our differential equation. We have the third derivative of y. So we do the first derivative and second derivative and the third derivative, and then we just put all derivatives back into our differential equation. And then we take x to the power m out. So inside here we would get so x to the power m can't be equal to 0, so only that can be 0. Take m out. Now m is equal to 0 and plus minus square root I. So we can say that y is equal to C1. This is case 1 and this is case 3. Case 3 said that if you have m equal to a plus minus bi, then you would get x to the power a, which is 0, c2 cos square root 2 ln x plus c3 sine square root 2 ln x. Which is the answer is the same, but the way that you do it just depends. Like you can do either way by assume x is equal to exponential of t, or you can assume as y is equal to x to the power of m. But for assuming y is equal to x to the power of m, then you got to remember another 4 cases in order to answer this equation.